In this experiment, we shall determine the temperature coefficient of resistance of copper. In part 1, we shall use the resistance meter method. In this experiment, we shall require the following apparatus: an electric stove, a magnetic stirrer, a beaker full of water, copper wire in the form of a coil, a thermometer, and finally a resistance meter. We start the experiment by switching on the electric stove, and then we set the speed of the magnetic stirrer. As the magnet spins, this will stir the water, and it will ensure that the temperature of the water is uniform throughout. We then read the temperature, followed by the resistance of the copper wire. We shall repeat measurements every 10 degrees Celsius up to a final temperature of 80 degrees. We repeat the experiment to get another set of readings, and then we record all the data in a table as shown. We plot a graph of resistance against temperature. This gives us a straight line with a gradient and intercept. Then we determine the temperature coefficient of resistance by dividing the gradient by the y-intercept and work out the percentage error for this result. In this part 2, we use the voltmeter and the meter method. For this experiment, we require an electric circuit. This circuit consists of a switch, a fixed resistance connected in series to the copper wire, and this allows us to split the voltage into two, a cell to drive the circuit, the voltmeter and a meter. The circuit diagram shows that the voltmeter is in parallel and the meter is in series to the copper wire. We switch on the electric stove and the magnetic stirrer. We also switch on the circuit to read the initial voltage, current and temperature. As the magnet spins in the water, the temperature of the water is distributed uniformly. We note that the voltage and current change with temperature. We continue to read values every 10 degrees Celsius until we finally reach the temperature of 80 degrees Celsius. We repeat the experiment to get another set of readings, and then we record all the data in a table. We find the resistance of the copper by dividing voltage and current. We plot a graph of resistance and temperature, giving us a gradient and an intercept. Temperature coefficient of resistance is found by dividing the gradient by the y-intercept. And then we find the percentage error for this result. For the last part 3, we shall use the Wheaton bridge method. In this experiment, we require the Wheaton bridge. It consists of a 1 meter long resistance wire mounted on a ruler. The two ends of this wire are connected to a cell to drive the circuit, and a switch. To the same wire we connect a 5 ohm standard resistor, a center zero galvanometer with a free end we call jockey, and the copper wire. We require an electric stove to heat up the water in the beaker, a magnetic stirrer to maintain uniform temperature, the copper wire coil, and a thermometer. The circuit diagram shows the Wheaton bridge with the resistor and the copper coil connected. We start the experiment by switching on the bridge and using the free end or jockey to check for balance condition. So we touch the wire at two extreme points to see that the needle deflects on both sides of the zero. Then we try to find the balance position. This position occurs when the needle goes to zero. We shall never slide the jockey along the wire. When we find the balance point, we read this length called L1 and the temperature. From this length L1, we can find the resistance of the copper wire. We switch on the electric stove and the stirrer. As the magnet spins, it stirs the water, and we wait for the temperature to rise. When the temperature reaches a certain value we have in mind, then we will switch on the bridge and find the balance point. We always switch off the bridge when not in use and wait for the next temperature to be reached. We repeat the readings every 10 degrees Celsius. We repeat the experiment for another set of readings. In the diagram we shall note that the equation has changed a little bit because we have swapped the connections of the copper wire and the 5 ohm resistor. As we can see, the bridge now is on the right hand side of the electric stove and the 5 ohm resistor is to the right of the bridge. We read the temperature and find the balance point on the bridge, so that this balance point will determine the resistance of the copper wire at this temperature. We switch on the circuit and using the free end or the jockey, we place it on the wire at different points until the galvanometer reads 0. That would be the point where balance point is found. We read L1 and switch off. Now we switch on the electric stove and repeat these readings every 10 degrees Celsius on the thermometer. We record all the values in a table using the equations shown at the bottom of the screen, and then we plot a graph of resistance against temperature. It gives us an intercept and a gradient, from which we can find the temperature coefficient of resistance of copper. We divide the gradient by the y-intercept, and finally we get the percentage error. Now in the last screen, we compare all the values for the 3 different experiments to find the temperature coefficient of copper.